Okay, so I just wanted to get a quick little study session in. I'm going to pick up where I left off with the control flow unit for the Thinkful bootcamp prep course. So click out of that. Okay, so I went over control flow a little bit. I think I'm halfway through this. Let me see. So I went over conditional statements a little bit and what that looks like using else blocks. So you have the if and then the condition and then the outcome of that. You can set, like for example, if someone's logging in, you can set a message if they successfully logged in, or if they haven't logged in yet, you can set a reminder for that. That's kind of how this functions. Oh, it's right there. So the true false Boolean type method, I guess. So that's kind of what that looks like. Let me see, did I do this REPL yet? I think I did do that REPL. Oh, and then I went over equality. So I have the double equal sign and then the triple equal sign, and the lesson basically said to use the triple equal sign more than the double because the triple will equal strict equality, it says right here, because it's predictable and you know what you're working with. It isn't loose like the double equality. I think it was with the double equality that it tries to convert the string. It says it actually right here. So the double equality operator turns the string 7 into the number 7 before checking whether the values are equal. So it will try and convert it before it checks, whereas the triple equals is strict and it will just check it and not convert it like that. Okay, so I went over that a little bit, and I think this is where I left off with the JS equality. To learn more about the difference between strict and loose equality checking in JavaScript, check out the video. I'm just going to review the video.
As you work with conditional statements, it's important to know that JavaScript has two visually similar, yet very different ways to test equality. You can test equality with double equals or triple equals. In this if-else statement, if we want to compare two variables, we'll want to use this comparison operator with triple equals to compare both the type and the value. Here, this is comparing that these are both strings and the values are both puppy. We can update these variables with numbers like this. And when we do the comparison, this is checking if they are both numbers and both with the value 25, which they are. Now, if item 2 was 30, it's pretty easy to see that although these are both numbers, that the values of 25 are not the same as 30. And this comparison would not be true, and they are different would be printed to the console. If you were to use double equals in each of these examples we just covered, we would actually still get the same result. Comparing the two strings of puppy is still true. The numbers 25 are still both true. And since 25 and 30 are not equal, this result is still false. So far, double equals and triple equals seem the same, but this is only because we have been comparing values from the same data types. So the difference between the double equals and triple equals is when the data type is different between the two, even if the value is the same. Let's look at item 1, which is initialized with the value of 25 as a number, but item 2 is the value of 25 as a string. If these were compared using the strict triple equals, then although the values are the same, the data types are different, and this would result as false in print, they are different, to the console. But if we change the triple equals to double equals, now before the values are compared, this loose equality comparison would try to convert the string into a number, and since the values are the same, this would result in the comparison being true and would print to the console that the variables are the same. So, the most important aspect to remember here is that the triple, or strict equality, compares both the data type and the value, and that the double, or loose equality, compares the value after trying to convert the data type.
So I'm just going to make a note of that. So loose equality
Type to match. The key
Gonna rewind that a little bit.
and the value.
I think that's the key takeaway right there.
Value. And that the double, or loose equality, compares the value after trying to convert the data type to match. The key thing to remember is that the type coercion can get a bit crazy in JavaScript. So while it is possible to use the double equals in JavaScript, you should really focus on only using the triple equals for all comparisons.
Assignment versus equality. Here's one very common mistake that new programmers make. They mix up the assignment operator and the comparison operator. In other words, they accidentally use a single equal sign to check for equality when they actually want to use the triple or double. Check out the code below. Can you identify what's going wrong? So looking at this, let current forecast equal sunny. That looks good. Okay, so that looks good for the triple, but that should probably also be changed. Only one equal sign means that this assigns rain to current forecasts instead of the triple equals, which would check if your current forecast is set to rain. If current forecast equals rain, let recommendation equal bring your umbrella. Okay, so we're going to open this replit. Okay, let's see what we need to do here. Change this to assignment instead of equality. Okay, so we can easily see that we just need to take away one of the equal signs because that means that we're assigning 7 instead of comparing it. Change this to check for equality. So checking for equality, we're going to add the triple equal sign. This should not be logged. Change this to a check for equality too. So that one can be double or triple. But since they want us to stick with the triple, I'm going to stick with the triple. The number was assigned correctly. Yay. Oops, I don't know why that's relational operators. Let's see what this is about.
Relational operators are useful to perform these 4 comparisons between values: less than, greater than, less than or equal to, and greater than or equal to. As we declare 2 variables, like x and y, and initialize them with values, we can use a simple console.log to print the Boolean outcomes from the comparisons. Here, 6 is greater than 2, so this will result in true. If we flip the greater than sign to less than, since 6 is not greater than 2, this result will print as false. You may have used symbols like these to represent greater than or equal to and less than or equal to. In JavaScript, these symbols are written like this, with the greater or less than sign and then the equal sign. So, if the values of x and y were both initialized with a value of 4, this console will print true for when x is 4 or any number larger. And if we were to flip the symbol from greater than or equal to less than or equal to, then this will be true when x is 4 or any number less than 4. These 4 comparisons are really useful when used with if statements in order to execute select blocks of code when certain conditions are met. Here is an if-else statement that says if the number of apples is greater than the number of oranges, then execute this code, else execute this code. In this example, there are 10 apples and 5 oranges. So with 10 being greater than 5 being true, this first block of code will execute. Taking some time to play around with printing the outcomes to the console or creating simple if statements to see how the values change the execution of the blocks of code will help you have a better understanding of relational operators.
In addition to the operators discussed above, JavaScript has many other operators that allow you to test and assess the relationship between two items. Although you don't need to memorize all the relational operators, you should know that they exist as you build your JavaScript skills. That way you can look them up when you need them. Remember, you can always refer to the documentation. Check out this list of relational operators. What patterns do you see? Okay, we have the greater than example here. 7 is greater than 4. True. 2 is greater than 10. False. 100 is greater than 100. False. So if they change that to 100 is greater than or equal to, that would be true. And then we have the less than examples. Very straightforward. Greater than or equal to. 7 is greater than 4. 2 is less than 10, and it's not equal, so it's false. And like I predicted with the one above for 100, that's true. Less than or equal to. Okay. Okay, so here they used, I can't remember what it's called in programming, but it's the exclamation point. I'm going to just look up what that's called again. Oh, it's called the bang. The exclamation mark symbol called a bang is the logical not operator. So it's like a reverse Uno type symbol. Yeah, I just Googled that. And so that's what it came up with. Okay, going back to the lesson. So that's called a bang, and it means not. Right there, it says not equal. 7 is not equal to 4. True. 2 is not equal to 10. True. 100 is not equal to 100, which is false. Makes sense. Okay, imagine that you're building a program for your company to track sales and expenditures. You want the program to send your colleagues an appropriate message when they've spent a certain amount of money. Check the REPL below and see how you can use relational operators to perform this task. Okay, so we're going to open this up. Okay, so we have our declaration up top for sales, inventory cost, and then let monthly summary message equal whatever the message is going to be in the quotations. Then we have our if statement. So if sales is greater than inventory cost, the monthly sales message is going to say, we made more than we spent. If the sales is less than the inventory cost, it's going to give this message. If the sales are equal to the inventory cost, it's going to say this. And then we're printing the monthly summary message, whichever one that will be. So we have our sales right there, and then we have our costs right there. And as we can see, they're equal. So we know that this message is going to say we broke even. Hooray! So we'll go ahead and run that. Okay. So I'm just trying to take in how it's formatted. So I'm really just taking my time looking over things with these REPLs. Would that change anything if we did a triple equal? No, it wouldn't. Okay, I'm going to go back to the lesson now. Oop, what happened to my screen? Let me share my screen. Using else if you have multiple conditions that you want to check, you can use if, and else to check them one after the other. So we have let login count equal 3. If login count is greater than 10, then it's going to give these statements. So if it's greater than 10, then it's going to say, that's a lot of logins today, champ, maybe give it a rest. And then we have our if else statement, login count is greater than 0. Console.log, thanks for logging in. And then our else, we're going to print, don't forget to log in today. As you can see, instead of only providing an else block, you can make another decision. In the above example, there are 3 branches to the condition. So we have this one. If it exceeds that attempt of 10, then they'll get that message. But if it's 0, if it's from 0 to 10, it will give this message. And then if it's nothing, it'll print that message. So that's kind of how that works. All right, moving into logical operators. Often you'll want to code to handle several conditions at once. You'll want it to consider a specific combination of conditions. For example, you might want to check that a user's password is long enough and that their chosen username is available. That's where logical operators come in, operators that test whether a given condition is met. They combine Boolean values so that you can express more complex ideas in code, like this condition and that condition, this condition or that condition, and this condition but not that condition. The and, or, and not logical operators tell the code how to work with various pieces of information simultaneously. In JavaScript, the 3 logical operators are written as follows: and, or, and not. So we know we're familiar with the exclamation mark, aka bang, aka not. These are new to us. So that's going to be or, that's going to be and. So we have an example right here. Let user logged in equal true. Let user purchased item equal false. So test if both values are true, user logged in and user purchased item. Test if either value is true, user logged in or user purchased item. And then this one is inverted. So it's just going to be not user didn't log in and they didn't purchase an item. When you read the code above, you'll notice several things. And evaluates to true if the values on both sides are true, or evaluates to true if either one of the values is true. Not works on just one value and gives the opposite of a value. Therefore, true evaluates to false and false evaluates to true. Okay, so looking back there, we can see how that works. Because up here we had this purchase, declared it false. Down here, if we put our bang in front of it, it's going to be true. And here is a summary in JavaScript. I'm just going to make a note of our logical operators. Kind of just keep track. I am going to have to get going with my day pretty soon, but I did just want to get a quick study session in. I'm going to try and finish up at least to this video or this replit, and then I'll probably have to log off here. But I guess just going over these logical operators was helpful. So I'm almost done with control flow. I might hop on a little bit later and do another live session if I have time and finish up this module or this little unit here. We'll have to see. So here is a summary in JavaScript, and do both sides evaluate to true. So true and true returns true. True and false returns false. False and true returns false. Or does either side evaluate to true? True and true return true. True false returns true. And then false. So this is helpful just to see kind of how it works. I like that layout. Not return the inverse. So that is going to be, of course, false and then true. The following video takes a deeper look into logical operators. Operators that test whether a given condition is met. I like to read the definitions just so that I can remember what that is.
There are three logical operators used to check whether an expression is true or false. And, represented by double ampersands, or represented by double pipes, and not. There are three logical operators used to check whether an expression is true or false. And, represented by double ampersands, or represented by double pipes, and not represented by an exclamation point. Here is an example of the logical AND operator. We declared a variable called outcome, and this logical AND operator will return a single true or false value based on the values of x and y. Here is a chart that will help us understand the various outcomes that are possible. So, with this AND operator, only when both x and y are true will the outcome be true. If x or y or both are false, then the outcome of x and y will be false. This can seem a little abstract at first, but what if we were checking if a user was logged in and they had something in their shopping cart? Here we have new variables for these two options with values. Within this if statement, we are checking if both user logged in is true and user item in cart is true. Remember, the number 2 will be treated as a true value, where 0 would be viewed as a false value. So this is an easy way for us to know that yes, the user is logged in and they have at least one item in their cart. And there could be times when you want to use the AND operator to help identify when two different conditions are true, like in this case, when we want to know if x is greater than 100 and also less than 150. Only when this first condition and the second condition are true will this block of code be executed. Otherwise, this block of code will be executed. Here's a simple example of the logical OR operator. We declared a variable called outcome, and this logical OR operator will return a single true or false value based on the values of x or y. In this chart, we can see all the outcomes working with the OR operator. X or y would be true whenever at least one of them is true. Only when both x and y are false would this outcome be false. Again, this can seem a little abstract at first, but what if we were checking if a user was over the age of 25 or had a certain license for a certain activity? Here, we have new variables for these two options with values. Within this if statement, we are checking if either the user age is 25 or older or the user license is true. In this case, the user is only 23, so this first condition is false. But the user has a license, and since this is true, then this if statement will be seen as true, and this block of code will be executed. Here is a simple example of the logical NOT operator. First, let's declare a variable called outcome, and it has a value of true. And that true value here will be printed to the console. Now, what if we added the NOT operator in front of the true value? Now this is changing the outcome by flipping its value. In this case, flipping the value from true to false, which we can see in the console. Here are a number of situations where the logical NOT operator is flipping the value. Where x is true, not x is false. When x is false, not x is true. We can also test this within JavaScript, where not true is false and not false is true. For all of these examples, the inverse will be printed to the console. Once again, this can seem a little abstract at first, but what if we were checking if a user's cart was empty or not? Here, we have a new variable with a value, and if we name the variable well, the statement makes a lot more sense. Here, we are checking if there are not items in the cart. If that is true, then we'll execute this block of code. And if the value is not 0 or true, then this will not flip that value, viewing the statement as false, which would then execute this block of code here. Another use of the NOT operator is with the equality comparison operator. In this statement, this is currently checking if item 1 is the same data type and value of item 2. If we wanted to, we could always update the comparison to check if item 1 is not the same data type and value as item 2 by replacing the first equals with an exclamation mark like this, and swapping the messages will print to the console like this. Since in this case, 25 is not the same value as 30, this block of code will be executed. Taking some time playing around with all of this will help you have a better understanding of logical operators.
Okay, looks like we have a REPL. To practice using logical operators, play around with REPL below. Okay. So just kind of looking at this, we have current forecast rainy, current wind speed 40, holiday false, current day Monday. So we have our if conditional statements down below. So if current forecast is rainy or current forecast is snowing and current wind speed is above 30, then this message will play out. Okay, so it looks like this message won't play because our current wind speed is not 30, it's below 30. So else it's not super scary and it might be nice. So we have this first chunk forecast for plus current day, Monday is, and then whatever the message is. So for this, it will be forecast for Monday is, it's not super scary and it might be nice. And then we have down here more conditions. So if current forecast is not sunny, it won't be sunny today. If we have more conditions, it's not a holiday, you can't take today off. So we'll see what runs here, what prints. Forecast for Monday is very scary outside, stay indoors. And then we have the additional messages of you can't take today off, because as we can see, we had our holiday set to false, but with our condition that inverted it, so it's true, which is why it printed. And then down here we have it won't be sunny today, because again we have our current forecast, which is inverted again with our bang symbol, which is why it printed it won't be sunny today. So it's going to take some getting used to, kind of playing around with the logical operators, I think, but that was a good little lesson to go over. Looks like up next is going to be order of operations. And then a Boolean guessing game, going over truthy and falsy values. So this unit covers quite a bit. Have a little bit of a knowledge check, and then we're going to help our pretend client. So hopefully I can finish this today and then move into collecting data with arrays, but I just want to get a quick study session in. I have to go now. Let me go back to where I was. But yeah, basically went over logical operators, which I did learn some new things there. I learned that operators are just used to check whether an expression is true and false. There are the conditional statements that can be set in there. So I'm going to play around with that more, but I'm logging off now.